welcome back. So today what we're going to look at is more algebra. This video will particularly focus on solving linear equations. So I've kind of broken up the things that we hopefully should know by now, the things that we should have a decent idea of, and then what is probably new to us and what we're going to look at today. So we should know what variables are, constants, coefficients. Just to run through those very briefly, variable is an unknown value. It varies, typically represented by x or y or another letter. A constant is a number that we know and we're familiar with. It's constantly the same, never changes. So an example of that would be 2 minus 10, 5,000 minus a million. And then coefficient, that's the number that precedes the variable. So if we had 2x, well, the variable is x, but the coefficient is 2. It's the number that comes before it. Okay, we should hopefully have a decent idea of our algebraic multiplication and division. If not, have a look at the last video in the algebra section. And then today we're going to focus on linear equations and how to solve them. So something that will be quite important to us throughout these questions in particular, and of course the whole Leaving Cert and Junior Cert course, is just that we know what opposite operations are. And these might seem really obvious to some people, not so obvious to others, but you can be guaranteed they will come up a lot throughout your secondary school career. So the basics of it are: the opposite of adding two things is to subtract them. So 2 plus 2, well, the opposite of that is 2 minus 2, okay? The opposite of multiplication is division. So if we wanted to undo a multiplication, we could achieve that by dividing. Yeah, so an example of that would be, 2 times 5 is 10. Well, 10 divided by 5 brings me back to 2, okay? And then my final one here, and of course there's more, but these are all we need to know for now, is that the opposite of squaring a number is our square root. So the opposite of multiplying a number by itself is our square root sign. Okay, and that can be achieved through mental arithmetic, and for some larger numbers we will have to use our calculators to find that solution. So here we have an example of two linear equations. The one on the left is pretty basic, the one on the right is slightly more complex, but it shouldn't be too troublesome. We should be familiar with these from junior cycle, and obviously they come up all the way through the Leaving Cert and senior cycle as well. So our goal of this is to find the value of the variable, and we can see in this one we have a variable of x. The coefficient is 2, so we have 2x. We have a constant of 4 and another constant of 2. So our goal here is, first of all, to get all of our constants on one side, and the side that I'm going to bring all those to is over to the right hand side. So at the moment I have a plus 4 on the left hand side of the equal sign. If I want to move that, I will have to subtract 4 from both sides, or another way that perhaps we've heard it is that you're moving it over the equal sign, and when we do that it changes sign. Okay, so what we should have here is that 2x is equal to 2 minus 4. 2x is equal to 2 take 4, well, that leaves me with minus 2. Okay, so now I've kind of solved it nearly for my final solution, but I know that 2x is equal to minus 2, but we're typically concerned with 1x, plus 1x, or just x on its own. What does that equal? Well, at the minute we have 2 times x is equal to minus 2, so our way to kind of undo that is to divide both sides by 2, because that x is being multiplied by 2. Those two guys will cancel for us and leave us with x minus 2 divided by 2. Well, that leaves me with minus 1. Okay, and that's our solution to that very first part there. Now if we look at our second part, we need to multiply out our bracket first, and then we can think about moving things around. So if I were to multiply out that bracket, I'd have 3 times 2, which would give me 6. I would have 3 times minus x, which would give me minus 3x. Okay, I would have that still equal to minus 9. Now let's make sure we can get our constants, or our numbers, all on one side. I have a plus 6 here, so what I'm going to do is subtract 6 from both sides, or In other words, move it across the equal sign and change its sign. Those two guys cancel. That leaves me with minus 3x is equal to, okay, minus 9, take away another 6. That leaves me with minus 15. Okay, and just as we did in our last example, we have a coefficient in front of our variable and it's minus 3. So in order to get rid of that, we think back to what our opposite operations are. The opposite of multiplication is division. So I'm going to divide both sides by minus 3. These two guys cancel, or minus 3 goes into minus 3 once. Minus 3 goes into minus 15 5 times. So our solution here is x is equal to 5. So the example we have here is more complex again, and we'll just work our way through this. So my first thing here that I would like to recognize with each of these fractions in particular is I'd like to recognize the lowest common denominator. Now there are a variety of ways that we can approach and solve these problems, but the first thing I'm going to do is just recognize that lowest common denominator. So we can see obviously we have 1/5, we have 3x over 10, and that minus 7, although it's not over a fraction, it's technically over 1, because anything over 1 is just itself. So what is the lowest common denominator of 5, 1, and 10? And hopefully we can realize that that is 10. 10 is the lowest common denominator of each of those denominators. And now that I've recognized that, my goal now is to multiply each element of the equation by 10. And we should see that help us out a little bit. So what that might look like, again, a few ways to approach this. We have 10 times 1/5 times x plus 3. So that's the same as this line here. I've just multiplied it by 10 like I said I would. Minus 10 times 7 over 1 is equal to 10 times 3x over 10, okay? And that is that next step gone out fully for me. And now I can start to do my multiplication, and then I'll be on to my simplifying and solving. Okay, so 10 times 1/5, well, that would give me 10 over 5, and 10 over 5 is 2. So that would essentially be 2 times x plus 3. So all I did was I multiplied these two guys out, and my x plus 3 came down. Minus 10 times 7, well, that would be 70 over 1, which is fine. And then 10 times 3x, that would give me 30x over 10. Okay, now to multiply these out once more, 2 times x would give me 2x, 2 times 3 would give me 6, minus 70. I'm just going to leave out the over 1 this time, because it's the same thing. Anything over 1 is itself. Okay, and then we have 30x over 10. Well, 10 goes into 30x 3x times. Another way we could have considered that was, well, we have a division by 10 and a multiplication by 10, and as we discussed earlier, they are opposites, so they would cancel. It would leave us with our 3x anyway. So that's another way to consider that particular part. Alright, and now it's a case of tidying up. We would like our variables on one side, our constants on the other. So that means that I'm going to subtract 2x from both sides. So minus 2x minus 2x. These two guys cancel. I have plus 6, okay, and minus 70. Well, that would give me minus 64. 3x, take away 2x. Well, that just gives me 1x, or just x. So here we have found that x is equal to minus 64. And that is our final solution to this part here. They could ask us to verify, and we'll go through the verification process in our next example here. Okay. So this one may be slightly easier because it doesn't have any fractions, but let's work our way through it. So again, we multiply out. We can see here that our variable is a, so it's all of the a's. We have our constants, and we also have coefficients here for a, and we will discover some more coefficients as we go along. So first things first, we have 3 times 4a, well, that gives me 12a. 3 times minus 6 gives me minus 18, plus 25 times a gives me 25a. 25 times 2 gives me 50, and that is still equal to a minus 4. And what we do now is we would like to move our variables to one side and our constants to the other. So I'm actually going to bring all of my variables to the left, and I'm going to make sure I have all my constants over on the right. So if we kind of keep in line with what we were doing there, to get my variables over here on the left, I need to subtract a from both sides. Okay, and now to get my numbers over on the right hand side, I'll just use a different color. I will have to add 18 to both sides, and I will have to subtract 50 from both sides as well. And I could have made my life slightly easier here by combining things initially. Like I could have had 50 minus 18 and then just move the solution of that, which would be 32, but I'm just going to do it the longer way here for now. So on my left hand side, what I'm left with is 12a plus 25a minus a is equal to, now those guys have cancelled for me, minus 4 plus 18 minus 50, and as a result of those moves, they've cancelled for me. And now this is something that I just need to tidy up, and I will have maybe 2 more steps to this question now. So 12a plus 25a, that gives me 37a. 37a minus a gives me 36a. Okay, I have minus 4 and minus 50 would give me minus 54. Okay, and now minus 54 plus 18. Well, minus 54 plus 18, that would leave me with minus 36. So 36a is equal to minus 36. Okay, we have a coefficient there in front of our variable, or a number in front of the a, in other words. It's being multiplied. Opposite of multiplication is division. Let's divide both sides by 36. 36 goes into 36a 1a times, or just a times, and now minus 36 divided by 36, well, that just gives me minus 1. So in other words, a is equal to minus 1. Right, and if we were asked to verify this, let's just briefly go through how we would achieve that. Well, we take our very top line there. I'm just going to write that out again. So it was 3 times 4a minus 6 plus 25 times a plus 2 was equal to a minus 4. And what we said in our last solution there was that we found out that a was equal to minus 1. And if we want to verify that answer of a is equal to minus 1, all we need to do is sub in minus 1 everywhere we see a in this equation, and we're going to check if it makes sense to us at the end of the process. So we would have 3 times 4 times minus 1 instead of a, minus 6 plus 25 times minus 1 plus 2 is equal to minus 1 minus 4. And let's start to calculate this. 4 times minus 1 is minus 4. Minus 4, take away another 6, well, that is minus 10. Alright, plus 25 times minus 1 plus 2, that's just plus 1, and minus 1 minus 4, well, that is minus 5. Okay, 3 times minus 10 is minus 30, 25 times 1 is 25. We're expecting that this should equal minus 5, and let's do the calculation. Minus 30 plus 25, well, that gives me minus 5. And there we have minus 5 is equal to minus 5. We think for a second, is that true? Yes, it is. They're both constants of the same value. Minus 5 is equal to minus 5. So what that means for us is that we have verified it. Our solution was minus 1. We were right. And finally, just to recap over what we've covered here. Again, things that we should have known, hopefully prior to the video, was variables, constants, coefficients. What are they? What do they look like? Where would we see them? We hopefully will have a better grasp of algebraic multiplication and hopefully a bit of division from those questions we've gone through. And then our last part, which is what we wanted to cover today, was solving our linear equations. To be successful in doing this, we should be able to effectively identify linear equations, and the way that we will notice that it's linear is that it has no exponents or no powers visible, or in other words, the highest power that we would see is to the power of 1. And it's an equation if it has an equal sign, if it's equal to something else, and that constitutes our linear equation. And of course, by solving it, what we're looking to do is break it down and find the value of whatever variable is presented to us.